Hello, everyone. This is Michael Sims from the Pacific Science Center and our virtual planetarium experience. Just thank everyone for coming to check out what we have in the nighttime sky today. This planetarium, we are going to focus on things that we can see in the nighttime sky, being a great background astronomers today. So, just to get started, we have our virtual planetarium, our simulation of what is going to be up in the nighttime sky. This is a simulation. It's using real data, just like from our own planetarium in the Willard Smith. And there's just a few key things that we're going to need to be really effective background astronomers. And that's what we're going to focus on today, because the nighttime sky this summer is fantastic. We have some beautiful planets, really bright constellations. There's even a comet for us to see. But before we get started, one housekeeping thing. If you have any questions, I really like making this interactive. I am free to go wherever you all want to go in the nighttime sky. And so if you have any questions or if there's anything that you want to see, feel free to just pop that into the chat, which I guess is actually over there. And my friend Zita Strickland, she's also in PacSci, a Pacific Science Center educator, and she's going to be able to help communicate any questions that you might have about the nighttime sky, what we're looking at, or anything else that just comes up to mind. Like we said, curiosity never closes, so keep on asking those questions. All right, let's get started with what is out in the nighttime sky tonight and how to be a really good backyard astronomer, even if you don't have a backyard. The first thing we're going to look at is this beautiful, beautiful simulation of where we are in the nighttime sky. This is a simulation, so I realize not all of us have a pastoral view, but all of this is coming from data. And as you can see, I've actually set the data so that it is right on top of the Pacific Science Center. Oh, you know what? Let's just go ahead and move this to the Willard Smith Planetarium. Great. Now, all of the stars that we're going to see tonight, all of their brightness, their location, their motion across the sky, it's all going to be based on some real data that's going to be visualized. The only thing that's not real is just this landscape that's, it's just a simulation to help us find where the horizon is. Now, to be a good backyard astronomer, there are a few things that we need to be able to communicate with each other. The first one is where to find something in the sky. And you're going to need three things to do that. The first thing is, well, this S right here. This S means I'm pointed south. You're going to need your cardinal directions. That helps orient the other viewers who are also joining you in the nighttime sky and looking at different objects to know where to face. So just remember, never eat soggy waffles. North, east, south, west. That can help orient the other person to look in a specific direction. So there's the south part of the sky. And then if I just scroll over and just turn to my right, there's the west side of the sky. The other big thing that we're going to need is time. You see, you're on a big ball. You are constantly spinning, and you're spinning around and around on this big ball, the Earth. That makes it look like the stars and the planets and everything is moving. And because it's moving, we got to be paying attention to time a little bit. So I've set our schedule right now. Everything is moving right now. Here's the dates. It is 3:34 and 46 seconds, 47, 48. And this time is really important because as we move time forward, things appear to be moving. For example, just over to the west near the horizon next to this tree, I see a nice crescent moon that is just dipping down below the horizon, and just a little bit far up, even during the daytime, it is possible to see Venus, which might mean that we must be close to sunset. If we just keep our eye on Venus and eye on the moon, and we fast forward time, think about that pattern across the sky as we move. We're going to spin and spin and spin. And so the moon, Venus, and the sun, which was high in the sky, moves from the east to the west until we have a beautiful sunset. Sunset around today is going to be just a little bit before 9:50. And so if we keep on moving, oh yeah, the stars come out at night. That is cool. That is beautiful. And because there are so many really cool things, I'm just going to pan around to my favorite thing in the nighttime sky that you're going to be able to see tonight. This is the one thing, if you leave this planetarium show, or if you see the entire thing, this is the one thing I want you to be looking out for tonight, because it is a beautiful clear sky, and this is a rare occurrence. In order to find it, we're going to be looking towards the horizon, almost due north, just barely over to the left, in a constellation called Lynx, and it is this. C2020 F3. It's better to know, if you need to Google it, just call it Neowise. This is a comet. It has been a very long time since we've been able to see a comet this bright in the nighttime sky. This is a fantastic thing to see, because not only do you don't even need binoculars, you can see it with your naked eye. It's been like 23 years since we've had a comet this bright. This comet, well, in a full field of stars, might be a little bit tricky to see. So all we need to know is those three fundamental things, or four fundamental things about how to communicate where it is. First things first, we are looking about a little bit after sunset. Let's do like an hour after sunset. That means that the nighttime sky gets really dark. A lot of the people who are at home not doing stargazing are going to turn off the lights so the light pollutions go away. You could also go out farther away into places that don't have as much lights, Tiger Mountain, for example, or up in Issaquah, past Issaquah. Just kind of get away from that city glow, but look north. The next thing you're going to do is find a very special constellation up to the north. This time of year and this time of night, the 7 stars of this Big Dipper are going to be on the northeast part of the sky. They are going to be halfway in between the horizon and what we call the very top of the sky. If you point it straight up, this is what we call the zenith. So we have the horizon and the zenith. So in order to find the Big Dipper, just look north a little bit to the east, halfway between the horizon and the zenith, and you're going to find the 7 sages. That's what they call them in India. But this is the Big Dipper. And if you just imagine the Big Dipper pouring out its water right now, it's going to be pouring the water almost straight down, almost right on top of that rock, on top of Neowise, that comet. And that's a great way to find a comet. Or, and this is just for this night only, if you take the bottom 2 stars of the Big Dipper and point straight down to the north horizon, just follow that line, then you're going to have a chance to follow the comet. Allie has a great question about planets, and there are going to be some planets we're going to be able to see out tonight. They're going to be on the south part of our sky, and we're going to get to them really soon. In the meantime, I want to show off just how well that actually looks. This is an example of using a constellation to help us map out what's inside the sky. You see the Big Dipper, or the plow, or the wagon, or the teapot, or the 7 sages, or whatever you end up on it. It's just an asterism. It's just it's like a pattern in the sky that you can actually see. It's not actually a constellation in itself. It's a part of a bigger constellation called the Big Bear, or Ursa Major. And we could actually see how close it is to Neowise. We use constellations to map out other things that are in the sky. So it's almost like the Big Bear, if you can see that Big Dipper with the nose, and then there's her front paw. It's almost like the Big Bear wants to eat it, like it's a blueberry or something that you're going to see in the sky. That's a good example of how to actually use a constellation in the sky. And that's how astronomers use constellations. So for example, we don't actually see Neowise inside the Big Dipper. Neowise for an astronomer is inside a constellation called Lynx. So that may be another thing I might say is, in order to find Neowise, the comet, the best thing you could do is look up north, around an hour after sunset. So you have that direction, you have the time. It's really close to the horizon. And then I might give you a constellation to look for. Lynx is not that great of a constellation to find. The stars aren't as dim, and Lynx is just a string of stars. And so you really have to use your imagination to figure out where in the sky this particular constellation is. What's important for astronomers is, you see this right here? This is the boundary of the constellation. So they say that anything that's inside of this constellation is inside of Lynx. And that's where Comets Neowise is right now. That's not always going to be true. That is really true for this night only. But like I said, you're on a big ball that spins. You're on a big ball that is revolving around the sun. And Neowise itself is traveling really, really fast right now. It just went around the sun, got to the closest point, the perihelion around the sun, around July 3rd, and it has been traveling out of our solar system ever since. And it's just now that it's become a nighttime viewing object instead of a really early morning viewing object. And so keep an eye again, let's play with time. This is the day today, but keep an eye on Neowise for where it might be in the nighttime sky at 11:30 as we go to tomorrow. And I just need a click a day. Come on, little guy, you could do it. I think it's thinking about it. It knows how to do it. All right, maybe if I press play again, it will kind of do it. If we follow time forward another day, what we're going to notice is that Neowise is going to move higher and higher up in the sky as it starts leaving our solar system. It has been a very, very long time since this comet has been to our neighborhood, been visible to the human eyes. This comet has basically it has an orbit around our sun that takes about 7,800 years to actually complete. So we have a good idea of when it was last year. It was around the time humans were basically domesticating a pig the last time this comet was here. So that's why it is really kind of a cool object to see in the sky. It's at night. As the week progresses and we move deeper and deeper into the week, Neowise is going to move up, 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 higher in the sky. And it's actually going to get dimmer, dimmer, and dimmer as it moves away from the sun. There's a whole lot of solar wind and cosmic radiation from the sun that's actually melting it, creating that massive tail that's tens of millions of miles long. It's going to be around July 22nd. It's going to be directly below that Big Dipper. If you take those past two stars of the Big Dipper, it's going to be right about there. So over the course of days, it's just going to move higher and higher into the sky, into the Big Dipper constellation. So if there's one thing that I want you all to look at tonight and communicate with your friends as you're looking at the nighttime sky is look north, near the horizon, an hour after the sun sets, and the constellation just outside your Ursa Major, and you're going to be finding a comet. Someone asked on chat, what is a comet? And that's a fantastic question. Comets are, well, they're giant snowballs. They're dirty giant snowballs that were kind of left over from when our solar system was created. They spend most of their time on the far, far reaches of our solar system. But they're basically giant snowballs. That little snow particles came together and ice particles came together and little dust came together just like they would form a planet. But these comets, they were just too small to actually form a planet. They formed little snowballs that now travel through space. Most of the time when they're in our solar system, that's how they actually look. They look like snowballs. But as they get closer to our sun and they orbit around the sun in the form of an oval, as they get closer to Jupiter, they start growing a tail. And the reason why they grow the tail is because there's all of this solar wind, this cosmic energy from the sun, magnetic energy and ionized particles, and the heat from the sun start melting the snowball. And so little jet streams inside the snowball, little pockets of it start to melt, turn into gas, and shoots out tails. And the tails could be massive, tens of millions of miles long. So that's what a comet is. It's a giant snowball that was kind of left over from when our solar system was first starting to form. And because it's really cold in space, they just stayed as little snowballs that move back and forth around our sun. That's a great question, and that's why it's so special. Oh, there's another great question about whether or not comets actually hit the Earth. And the truth of the matter is, we actually think they may have a very, very long time ago. You see, when the Earth was still forming, it was a big ball of fire and lava, and it needed to cool down to get those beautiful oceans and those rivers that we have today. And we think comets actually played a big role of returning water back to the surface of the Earth. So the next time you're taking the water, you might be able to actually be drinking what used to be an old comet. The other really cool thing is those big tails. Well, those particles that are left over from the comet that made those tails stay in a relatively safe orbit, and the Earth crashes into them. And they turn into really, really beautiful things in the nighttime sky. You might actually want to make a wish upon. They become shooting stars. So what would happen if a comet hits? Well, for the most part, what happens is that they just melt and burn up, and they look like shooting stars. And so you end up making a wish. Most of the time, they're tiny little things about the size of a grain of sand, and you make a wish because you see a streak of light go across the sky. These are great questions about comets. I like this. All right. I'm going to play with time a little bit more, and there's another story I have about the Big Bear. Let's see if we can actually move time again. There we go. And we could simulate where Comet Neowise is going to go after midnight tonight or after 11 o'clock. So what I would like for you all to do is look north and look for those 7 stages, the 7 stars of the Big Dipper. It looks like a giant spoon in the sky. And you follow these 2 stars right here, and you follow the path right up to this really bright star right there. It's almost like it's due north if you look at your compass, just off just a little bit. What I want you to observe is as we fast forward time, what happens to this star right here. So I'm going to take my little time thing, look at the Big Dipper over here, look at the Comet Neowise down there, and let's see what happens to the nighttime sky as we move the stars. We're getting later at night now. We're getting early in the morning. It's almost sunrise around 4:45 tomorrow. You can still see the Big Dipper now low in the sky. And it almost looked like all of the stars were moving around that one special star. And that's because you're a part of a big ball spinning around this one pole that all of the stars move around. That's the North Star. We're going to move it to the, now we're until tomorrow. So this is what the nighttime sky is going to look like at 11:30, July 15th. Oh, it still won't skip ahead a day for me. Well, shoot. This is the North Star. It is to the north, obviously, halfway between the zenith and the horizon. And you can see it at any time at night because it looks like it stays at the same spot. And all of the other stars look like or appear like they are spinning around it, either as time goes by, hour to hour, or as seasons go by. So we will see different stars during the different seasons. And that's one of the cool things about astronomy and being a backyard astronomer is you're going to see different constellations during different times of year. One of my favorite constellation stories that is out right now, specifically this time of year, is an asterism we call the Summer Triangle. To see it, we're going to go over to the east, and we're still about an hour after sunset. We're going to go up a little bit, closer to the zenith, almost like you're looking straight up to these 3 bright stars right there. This one's Vega, Deneb, and Altair. These are the Summer Triangle. They are actually made up of 3 different constellations. Vega, it is a part of a constellation called Lyra, which looks like a heart, a small version of a heart. Altair down below is a part of a constellation, Aquila, which looks like a giant eagle up in the sky. There's a special story that happens this time of year because Vega and Altair are so bright in the sky that we even created a holiday to celebrate it. This is a story that comes from the Chinese. And you can also hear it in Japanese culture and Korea. This is a story about Vega. Vega is the fourth brightest star in the nighttime sky. She's so bright, she's actually the princess of the sky, underneath the sun god, who's the brightest of them all. Well, one day, Vega was listening to a cow herder who was sitting underneath a tree taking a break from herding his cows. And he started playing a little harp. And he played this beautiful music, so beautiful that Vega instantly was fascinated and wanted to meet this beautiful musician. So the princess came down and visited the cowherder, and she fell in love. Oh, these two fell in such much love. Oh, and you know what happens when you fall in love? Well, sometimes you forget to be doing the things that you're supposed to be doing. And so the cowherd, well, they weren't being cleaned up after and anything like that. This made the sun god very upset, the god of heaven very upset. So he decided to separate the two lovers. And what they did was put Vega up in the sky and Altair up the sky, but create what we call the Milky Way, a river of stars in between the two, so wide and so bright in the sky that the two lovers can never meet. But Vega, she was very sad and heartbroken. So she got on her knees and she prayed to everyone for help. She prayed to the trees in the forest. She prayed to the fish in the sea. She even prayed to the wind in the air. And that's when the magpies heard her. These are special little black birds that one day out of each year fly across the river of the Milky Way and form a bridge where one day out of each year, Vega and Altair can see each other again. It's actually a Chinese holiday, Jinxin. It's celebrated when these stars are at their brightest on the 7th day of the 7th month of the 7th moon. This year, that's going to be celebrated on August 28th. But it's during the summertime that these two stars are the brightest. It's a story I really, really enjoy. If we take the summer triangle, which is Vega, Altair, and Deneb, and we follow its path, we would actually be following the Milky Way all the way down south. The Milky Way is fantastic, but the reason why I wanted to show you down south is that there's another special thing that is happening this week, and that has to do with Jupiter. In order to find Jupiter tonight, what you're going to have to do is look to the south. It's going to be close to the horizon. Planets during the summertime are a lot closer to the horizon than during the zenith. We're still about an hour after sunset. And it is just to the left of a constellation we call Sagittarius. Let's see if I did my spelling right. Sometimes I don't do my spelling right. All right, let's take that off. Sagittarius is kind of easy to find. It's even though it's a centaur, I always think of it as a teapot. You know, I'm a little teapot, short and stout. Here is my handle. Here is my spout. It's going to just be left of the handle or east of the handle of the Sagittarius. That's where you're going to find beautiful Jupiter. Just last night, Jupiter is in what we call opposition. Opposition means that, well, the Earth was directly in the middle between the sun on one side and Jupiter on the other. The Earth was in the middle, which means that Jupiter is particularly bright right now because it's almost like it's a full moon. It's a full Jupiter. So if you got some binoculars or a telescope and you looked at Jupiter, you're going to see the entire surface or entire phase of Jupiter. Jupiter is like one of those beautiful planets, and if we just go ahead and just blast off up into the sky, as a backyard astronomer with some binoculars, this might be pretty close to what you're going to notice in the sky. You're going to notice a tiny little object like that With some binoculars or a telescope, you will see some stripes, and then you'll see 4 star-like objects that kind of go around Jupiter. And it's actually kind of rare. You can see all 4. So this is just like a great summer to go star hunting. You're just going to have to keep on moving your telescope because as time travels, Jupiter and Ganymede and Callisto and its other moons are going to keep on moving. And that's because you're moving on that big ball. Right next to Jupiter in the nighttime sky, just next to it, and you're going to see it as the brightest thing in the nighttime sky in this area, is Saturn. Saturn's not necessarily in opposition, so you're not necessarily going to see the entire thing. It's not as bright as it usually could be. But with a telescope or something like that, you might be able to start seeing some of its rings kind of peeking out one of its phases. That's kind of like what it would look like as a telescope, except for you may not be able to see the entire thing. You might just be able to see, there might be some shadow still from the different phases that the planets might have. But Saturn is like one of those beautiful objects, and it looks like the rings are going to be tilted, which means that you can see the beautiful rings that stretch out for hundreds of thousands of kilometers, but are only about maybe a half a mile thick. Also to the south is Sagittarius, my favorite constellation. But, all right, backyard astronomers, don't be tricked, because after Saturn, after Jupiter, you're going to look on the other side of the Milky Way tonight. You're going to see this beautiful red star. It is going to look red. And you're going to think to yourself, that thing is too bright and too red to be anything other than Mars. Sorry, that's not Mars. It's a star we call the Antares. In fact, the name means Mars-like. Astronomers have been tricked a lot of times thinking that this is actually the Mars planet. What we actually find out is that Antares, this beautiful red giant of a star, is actually 2 stars. This other star is actually circling around Antares, and they kind of circle around each other. A lot of the stars you actually see at night do just that. Antares is a great star because it's beautiful, it's red, it shows a lot of color that you might see in the sky, because not every star is white. Stars have a variety of colors, and if you're a great backyard astronomer, I want you to all be looking out for that. Okay, Antares is a part of a constellation we call Scorpius. Scorpius is a beautiful constellation. It is a scorpion that got in a fight with Orion. The 2 got in a fight, and it was such an epic battle. I mean, it was causing earthquakes, how much they were actually fighting each other. And you know what happens when siblings get in a fight? The parents put them on opposite sides of the room. The same thing happens with constellations. When Scorpius and Orion got in a fight, they put them on opposite sides of the sky. So whenever you see Scorpius, you're not going to be able to see Orion. Whenever you see Orion, you're not going to be able to see Scorpius. So summer is the time of year that you see Scorpius. What I really like about Scorpius is that, well, that was kind of a Greek or a Western story. But in Polynesian culture, in like Hawaii and New Zealand and Fiji, this was known as Maui's fishhook. And legend has it, you know, just like Mona. And legend has it is that it's Maui's fishhook that swoops across and comes right back up in the sky that holds the Hawaiian Islands chained together. All right, so that was north, east, south. Let's just do one over to the west. It is a beautiful blue star called Spica. Just like you can use the stars to tell different seasons and tell time, Spica is one of those examples of how important it is to actually look at the stars to tell the seasons. Spica means wheat. And so whenever Virgo, who's in the constellation of Spica, let's see if we can sneak up there, grab that. There we go. Let's see if we can see Virgo. There she is. I'll zoom out just a little bit. She's holding a wreath of wheat. And basically what the Greeks used to figure out, and the Babylonians and the Egyptians, anytime that Spica started going below the horizon and can no longer be seen, That's when it was time to harvest its crops. But when Spica starts appearing east of the horizon and starts rising again, that's when it's time to start planting your crops. This is why Virgo, the maiden, actually spends half of her life and half of the year among the living, and then half of the year in the underworld among the dead, feeding both groups with her special wheat. To find Spica, use your constellations. So just like I said, up to the north, we're going to find that Big Dipper again together. The Big Dipper is almost due north. It is between the horizon and the zenith. And that's where I see over to the north and a little to the west, the seven sages, the Big Dipper, the plow. And I noticed that these are making an arc. So if I follow that arc down in the sky, I'm going to arc down to Arcturus, a yellow star that's a part of a constellation called Bootes. And then, as the backyard astronomer knows, you spike down, almost go straight down to Spica. So that's how you can use your constellations to map it with each other. What color? Oh, someone has a great question about what color of star is the hottest, and which color is the coldest. That's a great question. Spica, as we can see, is a blue star. And that means it is really, really, really hot. It is among the hottest. And it is actually going to be, well, you know how you like burn up and you spend a lot of energy and that makes you really, really tired? Spica is actually going to be among the youngest stars that we're going to see in the sky. And it's not going to actually live that much long. Then we have the red stars. They're not as hot, but they're really, really, really big. They are kind of like, hey, I am going to kind of chill out. I am going to be big and massive, and I'm going to move really slowly. I'm not going to cause as much heat, but I am going to take up my space. Those are those red stars, kind of like Antares over there. And then there's our star. It's somewhere in between. It's a middle-aged star and a middle hot and a middle size. It is just, you know what? It's almost like the Three Bears, Goldilocks and the Three Bears. It's just like ours just seems to be perfect to call home. That was a great question. I like that question. I'm going to go ahead and just for a few minutes, I know that we're past time, but I'm going to just for a few minutes, I'm going to put up all of the constellations that you might be able to see tonight. And then that way I can take a quick spin across the sky from north to south, from north to east to south to west, and just go ahead and let me know if there's any stories that you want to see about any of the constellations in the sky. So there's Lynx and the Big Dipper. There's Camelopardus. Let's go ahead and also see the lines that they make. Oh, there's Queen Cassiopeia with Perseus and Princess Andromeda. If you look at Princess Andromeda and the line that she makes, just right above her, you might notice this little cloud right there. That's the Andromeda Galaxy. That's our next door neighbor. There's Pegasus up the sky with big wings to help him fly really fast. Delphinius, the dolphin's up in the sky, really, really faint, but he's just right below Altair, the cowherder from the story. Capricornus is in the sky, in between, pointing the way towards Saturn and Jupiter, which we'll find an hour after sunset, due south, almost really, really close to the horizon, in the constellation Sagittarius. If you go out really far, you might be able to see that Milky Way, the big bulge of sky stars. That's your home. That's your galaxy. Every star you see at night all belongs to the Milky Way. That's where you live. Do stars die? Oh, somebody on chat is asking me a great question. Do stars die and which ones die first? That's a great question. It takes billions and billions of years for a star to live its entire life. But yeah, everything in the Milky Way and everything that we see in the sky is going to, well, I don't like to say die. They're going to change into something more beautiful. So Sometimes that takes in the form of they just kind of turn off. Sometimes that takes form of stars kind of collapse in on each other, and just like the gravity just kind of pushes it down and pushes it down until it creates what is essentially about the size of a planet, a diamond. And then sometimes they blow up into huge explosions. And then the gas from those stars gets together, joins up, and makes new stars. Which ones die first? Well, the faster you live and the hotter you live, the faster you're going to live through your life. And so the blue stars, the really hot stars, kind of actually die first. But the big ones, those are the ones that can make those massive explosions. Kind of like what you will see on Orion during the wintertime. There's Scorpius, and if you were curious about that other zodiac, there's Ophiuchus, kind of in the middle of the sky, in between zenith and the horizon, over to the south, right above the Milky Way. We have Virgo and Bootes. We have the Northern Crown, or as the Aborigines in Australia call it, the Boomerang, and the Big Dipper. And if you almost look straight up in the sky tonight, you'll find the biggest constellation in the Northern Hemisphere. This is Draco the Dragon. He slithers his way right in between the big and the little bear. All right, astronomers. So that's what your homework is going to be. So I want you to all look up north tonight, an hour after sunset, towards the north, near the horizon. See if you can find a Big Dipper and allow the Big Dipper to point your way to seeing a comet that we're not going to see again for another 6,000 plus years. Then after you've seen this comet, either with your eyes or with the binoculars, look due south. And there you're going to find beautiful Jupiter in its full brightness and Saturn. So keep on exploring with us. Curiosity never closes. Also, please help support us. We need donations to provide programs like these. We're working really, really hard to provide virtual education programs for classrooms and camps. We're also offering our own camps right now here at PacSci with a lot of safety measures, or virtual camps that you could do on the computer. And then finally, we do have a very, very special Science on the City next week. You see, at the end of this month, NASA is going to send a rocket to Mars. And so there's a Science on the City on Tuesday at 7 p.m. talking about this rocket, this mission, and what they hope to discover on another planet. So please support us and keep looking up in the nighttime sky. Thanks everyone for joining me. I really appreciated it. Have fun stargazing.